design guidelines. That is, first one is semantics of the attribute, and second one is reducing the redundant values in a tuple and reducing null values in a tuple and disallowing the possibility of generation of the spurious tuples. These are all what the 4 design guidelines for designing any database here or the good relational schema. Apart from that, we'll also discuss what is the need for the normalization. So the need for the normalization is, the first thing is used to remove the redundancy, and the second one is to maintain the record consistency or the accurate result, and the third one is show the lossless join property. That means even though if you split the relation, then after splitting the relation, if you try to join the relation, there should not be any loss of information here. That is what we call that as the join property, joinless property here. Because of all these 3, we'll go for normalization. So the next is, we'll see the functional dependency. What exactly the functional dependency? The functional dependency, what is that? What it says actually, which describe the relationship between the attributes in a given relationship, which are in a given relation, which is called actually the functional dependency. For example, if I take the student database here. So here actually in the student database, we'll have the attributes like USN, student name, and the class section like that. So here in this case, the USN, student name, class section, these are all the attributes here. How the attributes are dependent on the another one. For example, here the name attribute is always dependent on what exactly? Always dependent on the USN here. That is what we call that as the functional dependency. So the functional dependency is, it describes the relationship between the attributes in a given relation R. How the functional dependency is represented in set one notations is X determinant Y. You can see that this is what X determinant Y. This means that X is the left hand side attribute and Y is the right hand side attribute. You can see here X is the left hand side attribute, Y. So here Y is what exactly? The attribute Y. Here X is also attribute and Y is also attribute. Y is dependent on what exactly? X. How do we represent in diagrammatic form? How do we represent in set notation is X determinant Y. That means Y is dependent on the X here. Where X is called actually what? It's a member of the candidate key. Candidate key means what exactly? The each key attribute is called as the candidate key. So Y is non-key attribute and X is what exactly? The key attribute. That means Y, that is a non-key attribute, is dependent. What it says that non-key attribute is dependent on the key attribute. For example, the name of the student is dependent on the USN. Obviously, it has to be dependent. Otherwise, how do we justify or how do we differentiate from one particular the student to another? So you can differentiate the students based on your USN here. So the rule is what? There are actually the 2 rules is defined with respect to the functional dependency. That is X determinant Y. That means Y is dependent on the X and X is a member of the key. And X determinant Y is not equal to Y determinant X here. So that means it's not equal to. That means always the right hand side should be what exactly? There should be the non-key attribute and the left hand side should be the key attribute. How this functional dependencies can be written in the diagrammatic manner is, so this is what, how you used to write this schema diagram. In the same manner you write here. Here in this case, in this example, you can observe here SSN and E name is there. That is, employee name is dependent on what exactly? The social security number. So which is the non-key attribute here? Here E name is the non-key attribute and SSN is what exactly? SSN is the key attribute. So that E name is dependent on SSN. The arrow mark should be always shown towards what exactly? The non-key attribute. It's a reverse in case of a schema diagram. But when writing the schema diagram, the key arrow mark is always pointing towards what exactly? The key attribute here. But here in this case, So whenever if you are defining the functional dependency, the arrow mark is always pointing towards what exactly? The pointing towards the non-key attribute. This is one example. And another example, you can see that project number, project name and project location. Here the project name and project location, these two are the non-key attribute, means it's not a key attribute. But these two are dependent on what exactly? Dependent on the project number. So the project number is what exactly? Here it is a key attribute, and project name and project location both are what? Both are the non-key attribute here. So this is very important. Next, inference rules of functional dependency. This is very important, the topic in the exam. The last, explain the inference rules or write the inference rules of functional dependency. There are 6 inference rules of functional dependency. There are 6 inference rules of functional dependency. The first rule is, you have to make a note down of this. Reflexive rule. Reflexive, what it says that if x is a subset of y, then x determinant y. You have to state this reflexive rule. When actually these inference rules are used, is the next topic will have the minimal set of functional dependency. In such case, these rules are useful here. So reflexive rules means if x is a subset of y, then x determinant y. Next, augmentation rule. If x is a x determinant y, that means xz determinant yz. Augment means what? You are adding in one more attribute either on both the side, that is left hand side and right. Augmenting means adding an attribute here. Next, transitive rule. X determinant y, y determinant z, that equals to what exactly? X determinant z. You know that transitive rule. Next, decomposition or project rule. X determinant y, decompose means that removing one attribute, equal to x determinant y. Next, union or additive rule means x determinant y, x determinant z, which is equal to x determinant yz, because the left hand side attributes are same. Next, pseudo transitive rule means x determinant y, wy determinant z, which is equal to wx determinant z here. So all these rules that you have to remember. There are how many rules are there? There are totally the 6 inference rules of functional dependency. Here first 3 rules, that is reflexive rule, augmentation rule and transitive rules, are called as an Armstrong's rules. This may be called, comes for your MCQ. The reflexive, the augmentation and transitive rules, these 3, reflexive, augmentation and transitive rules, these 3 rules, these 3 are called as an what exactly? Called as an Armstrong's rules here. Next, trivial and non-trivial functional dependency. What is this? Trivial and non-trivial functional dependency. Let us take with the first one, that is trivial functional dependency. Trivial means a functional dependency is trivial if and only if the right hand side is a subset of the left hand side. The definition that you have to learn here. So when do we say that the functional dependency is the trivial means the right hand side attribute, it's a subset of the left hand side attribute, then that functional dependency is usually will be called it as a trivial here. Example, you can see that a comma b determinant b here. So the b is what exactly here? You can see the b is a right hand side attribute and AB is a left hand side attribute. Whether the right hand side attribute is a subset of left hand side? Yes. Then we say that this is a trivial functional dependency. Are you following, all of you? Are you following, students?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. A functional dependency is trivial if and only if the right hand side attribute is a subset of what? The left hand side attribute. Then example, you can see SSN comma name determinate SSN here. In this case, whether right hand side attribute is a subset of left hand side, whether it is a right hand side attribute is a subset of left hand side, say yes or no. Are you there in the class, all of you?
Yes, ma'am.
Yes, ma'am.
Then
Yes, ma'am.
is it the right hand side is a subset of left hand side? Hmm?
Yes, ma'am.
Then it
Yes,
is a
ma'am.
true. Next, non-trivial functional dependency. The non-trivial functional dependency means the right hand side attribute is not a subset of the left hand side attribute here. For example, you can see here A determinant B. The B is the right hand side attribute, A is the left hand side attribute. B is not a subset of the left hand side, right? So this is a non-trivial. Next, BC. All these two together is considered as one single. BC is not a subset of what exactly? The left hand side. Then it is a non-trivial. Then name. The name is not a subset of a left hand side. Then it is not a non-trivial. This is what we call that as a trivial and non-trivial functional dependency. Trivial functional dependency means the right hand side attribute is a subset of the left hand side attribute. Then we say that it is a trivial functional dependency. Non-trivial means the right hand side attribute is not an the subset of the left hand side attribute. Then we say that it is a non-trivial functional dependency. Next topic. This is very important. The topic in the exam they'll ask explain the or write an algorithm to determine the closure of X under F. Okay, write an algorithm to determine the closure of X under F. This is a question. Or else they'll give some functional dependency and they'll ask you to find out the closure of X under the functional dependency. The first algorithm. What algorithm says that? The first step. X closure is equal to X. That means whatever we have the functional dependency in the X, you replace or you transfer into an X closure. And you need to repeat until old X closure becomes an X here. This algorithm first you need to remember. Then we'll go according to an example, then you'll come to know. For each functional dependency, Y determinant Z in F. F means what? All sets of functional dependency. For each functional dependency, Y determinant Z in F, then take down the Y is a subset of the next closure, that is previous exclosure. Yes, if it is a subset of this, then you must add the right hand side attribute to what exactly? The exclosure. That is what? Exclosure is equal to exclosure union Z. Union means that you are going to add the Z to the exclosure. Like that. So here, you need to repeat until what exactly? Until you get the exclosure is equal to old exclosure. This is what an algorithm here. Is this algorithm is clear? The algorithm just takes 4 steps here. That is, first replace all the functional dependency to exclosure. Then we need to repeat until we'll get an old exclosure is equal to X. For each functional dependency Y determinant Z in F, if Y is a subset of exclosure, yes, then add Z to the exclosure. Until you have to repeat until where actually until you should get the exclosure is equal to old exclosure here. Now let us take one example along with this.